Screen's awfully black. All right, so the title is, what's the title again?
Quality and efficiency up, failed releases down.
That's the one. Well, anyway, what we're here to talk about is getting your dev, test, non-production databases better. What's the single best data set to work on for development? Production. What's the one data set that those nasty old DBA types say that you can't have? Production. Well, you know, businesses and all those fun people. Still dark.
Yeah.
Well, hang on, let's just... So the idea here is what we wanted to get to is realistic data, production-like data, but compliant. We have the About Me slides up right now. Nobody cares about Me slides. They really, really don't. And no one wants to know anything about me or David. No. Actually, maybe you want to know about David.
No, they don't.
But I have my contact information on there. If you have questions after today, please reach out if we can ever show it to you. But it's the only thing I ever say in About Me slides. I really don't care for them. No one wants to know how long I've been in the business. I have gray hair. Figure it out. I've been in it for a while. Dave, want to introduce yourself?
Yeah, so I'm one of the solutions engineers at Redgate, so I work alongside Grant. Been there for about 4 years now, but again, nobody cares, and also have grey hair.
It's not quite as much.
No, I cut it short.
All right, so we already said this. Single best data is for testing is for production. I worked on these slides, so I really want to show you.
The slides aren't so much the problem, but I think when we mime the demo aspect, it might be
I was
something.
going to say, I know, interpretive dance of the demo will definitely be a bad thing. By the way, for people who have never presented, this is common. I would offer my laptop, but we can't do the demo from that, so.
We might be back to the dance.
I've got 3 different adapters.
Can you go direct to HDMI? On the inside.
There's that one.
Oh,
There we go. That's what it took. It took me to have to dig into my bag.
There we go.
Hey, look, there's a thing on the screen. That's cool. All right, so why can't you have production data? Why is it locked away? This is one of the reasons. One of the reasons. Compliance is important. There's a lot of legal stuff going on. And if you're in the United States, this one's legitimately scary. It's HIPAA, Health Information Protection Availability Act, I think is actually what it means. Why is that one scary? Well, the GDPR will fine your organization a lot of money. California Privacy Rights Act will fine your organization a lot of money. The PCI will fine your organization a lot of money. The federal education, whatever it is, will fine your organization a lot of money. If you knowingly violate HIPAA, as an individual, you can be prosecuted by law. I personally do not wish to have a new roommate named Tiny, so I try to avoid violating HIPAA if I can at all, can. And so this is why we can't have production data. But there's one more reason. So, there I was. There's actually the rest of the phrase, I'm not going to say it all. Does anyone else know it? I'm not going to repeat it because it gets rude. There I was in the stuff with the grunts. No? No one knows that one? Maybe it's just an American saying. Anyway, there I was deploying a database to production. And the dev team says, yep, it's ready to go, it's tested, it's fine, get it out there. Cool. We deploy it to production. Deployment went fine, no big deal. Empty database. Load the data. Data load went fine, no issues, primes. Cool, everything's great. First query from the app goes in and doesn't come out. Ever. We waited 3 days. CPU is cooking. Memory's maxed, I/O is maxed. I mean, we can't measure everything just because the machine is so pegged. It literally runs 3 days, and then we turn it off. And it ran for 3 days because we're just like, this is cool. Let's see how long it takes. By the way, your production is broken. You should know that, but we don't even know what to do to fix it because queries aren't coming back. Come to find out, our dev team did not have production data because brand spanking new database, brand spanking new functionality and everything, but they tested it. They tested it thoroughly. They tested it all the time. They had a constant running stream of tests with one row. Production had more than one row, if anyone's shocked. And it didn't work at all. We literally had to go back for another couple of months of development for a product that was, quote, ready. Yeah, we were popular people.
As always.
As always. Anyway, why is test data important? David, why is test data important?
You might want some by the sound of the story.
Yeah, no kidding. The thing is data leads behavior. The data you have in your system dictates the way things behave. I mean, we can talk query tuning. You want to talk statistics. You want to talk about indexes. You want to talk about all that fun stuff. I'm in, man. It's cool. Data drives that. What kind of data you have in there drives performance. It drives all the other stuff. It also drives all the troubleshooting. I mean, if you've got bad data, it's going to cause errors in your code, or it's going to cause errors in the application, or worse yet, it's going to cause errors in the reports. And you might be a bank that didn't have any kind of protection stuff on their investments, which is weird, but sorry. America again. Anyway, you need it for troubleshooting. You need it for testing. And you need it for acceptance. You have to be able to cover all of this information, and you've got to have data in the databases in order to do it. Further, that data's got to look like production. Why? Well, because again, data leads behavior. The way the data is shaped, the number of rows in the tables, the actual values in the rows, the fact that your credit card, for those who don't know, has all kinds of weird little encoded information in it. What kind of bank issued you your credit card is in the number. What? Yeah, it's weird, but it's there. There's a whole bunch of other things about credit card information. So if you're doing credit card testing, you have to have a realistic looking credit card number. You can't just put in anything. It won't work. So data leads behavior. So we have to have data, and the data has to be realistic. You got anything to add to that one?
No, on that side it's good, but we are going to show you how you can do it, which is slightly revealing the magic of what we're going to do, but
cool.
We will get there.
Yeah. So the next challenge, entering the dungeon. Yes, I did do the D&D theme. Somebody had to. No, kidding. So the hard part, right? How are you going to get good data? All right, so first up, and this is brutally difficult. I will not lie, this is difficult. And I have another story on this one too, but we'll get to it. You have to decide what data is really important. Say, okay, well, GDPR. It doesn't tell me anything. What's personally identifying within our database? Well, okay, last name. Okay, cool, good. What about first name? Nah, it's not personally identifying. Well, aren't there unique names out there? There are not a lot of grants. I mean, there's a few, but there aren't a lot. So it's kind of close to personally identifying. All right, so we've got to go through and we've got to look at every bit of data and figure out what it is. Great. Who makes that call? Man, I'm just the database developer. What do I know? I can make the code run fast, but I have no idea what's personally identifying. So making the decision first on identifying all your data is really, really hard. Next step, data cleaning. I've got a story on that I will share. Who's heard my story before on data cleaning? Anybody? I mean, David knows it. I share it all the time because it's really one of the best stories. Okay, oh, cool. No one knows it. That's great. Anyone online know it? No. Cool. Awesome. We'll get to it. Don't worry. But cleaning data becomes really important. And not only that, but I mean, DBA's in the room. Who's straight up a DBA type? DBA type. It doesn't have to be DBA in your title. I mean, I know several people who's like, what's your title? Lead developer. What do you do? I'm a DBA. Cool. So DBA types. Half the room-ish. Okay, cool. And devs, straight up just dev types. Almost approximately the other half of the room. All right. Who am I not? What other types are we talking about? Test data. Cool. Okay. Good. A tester's great. No.
InfoSec is part of my role.
InfoSec. Okay, cool. That's a great one too. Anybody else? Any management? Awesome. We can make fun of them. Excellent. Cool. So data cleaning for the DBA types, they already know some of the problems you hit with data cleaning. How do you do it? Well, you know, it's no big deal. You just go in there and replace the email with something. What? I don't know. Something. Okay, great. We'll do that. How do you clean up the credit card data? Replace 444444444. Yeah, that won't work because of the rules about credit cards. Oh, right. Okay, so we have to make that. By the way, our database size is only 50 terabytes, so we'll just clean that up, 5 minutes, right? No. 5 days, maybe, ish, on a good, if the wind is blowing the right direction. So there's a lot of time involved for doing all this processing. And then finally, for all of you developers out there, half the room, we want to make it self-service, so you can just hit a button and it happens. Sorry. So this is hard, right? This is actually a challenge. This is a difficult thing to do. You are entering a dungeon, right? This is not simple. This is all really tough stuff. We're supposed to be back and forth.
We are. You are happily going. So from the getting started side, who has tried to get started? One?
Nobody's doing this?
Two?
Oh, cool. You're going to love my next story then.
Has anyone tried to get started and just given up at the first hurdle? There we go. We have a one. And what was the reason they fell apart?
Third-party vendor app, and the data isn't stored in the database, it's stored in the text file system.
I quit.
1970 that, still used now. So, was a big headache.
Yeah. The other guys that are, or have tried, successful?
Just too big.
What sort of size? Okay.
Oh, I forgot. I didn't repeat the thing.
Oh, yeah.
Yeah, they just had a third-party app that they didn't store the data in a database. They stored it in a flat file. No big deal. Oh, no, I know. Yeah, no, believe me. I'm being an American. Yeah, that's a gigantic big deal.
Yeah. So it's not always the technical limitation. It's not that always makes it fall over. It can be, any number of these things up here. You've got the business logic that you've got to put through. You've got the legality of being able to do it, whether it's then practical, whether it's usable, how you can get around that side. So there is a huge range of challenges when it comes to data management, including the technical, but way beyond it as well. And this is really something that everyone we talk to it always comes up. And you can get past the first hurdle, but there might be hurdle 2, hurdle 3, hurdle 4. So it's about accounting and planning for the longer term way that you're going to approach it. Exactly how are you going to do it? Whose needs are you going to meet? You know, you've got all the way from sort of complete privacy on one side, you can have completely private data that might be completely unusable to some teams. So then being able to bring that back into the workflow, so you've got that happy medium, that's really where we need to be able to do it. And from there, that's where you start to then think about the beginning steps, finding the way to tackle the data, to be able to tag it so you know what you're working with before you begin. Because often most of the people that we encounter, first problem is exactly what is there.
Right.
What are they going to be working with? You know, it's all well and good having the great intention to anonymize your data, but who in the organization has a clue where it is in the first place? You know, maybe you've got the development team, but are they the ones that are then being asked to work with the data set? If they're not, the person that's being asked, you know, I was working with a customer recently, and you know, it's very fun to figure out what data is in column JX7. It's like, there's names in there. Oh, good. Glad we know. And it becomes a very long process when you're querying every column that you're looking at and going, what is in there? And from there, the little hurdles that you can get over at the start then give you the way to kind of go forwards.
And you can start on common sense, right? I mean, that's the simplest place to start. Should we mask the credit card data? Or should we just put that on an unsecured dev laptop that we carry home and on the train, and there's no way it's going to get stolen? No way. Well, okay, common sense says, yeah, I mean, maybe it could get stolen, so probably giving the credit card information to the dev team is not a good idea. That's easy. But now what you need to do is start bringing in the business team. Because it's business, man. They have an understanding of the information on hand and what stuff, if someone saw this, it wouldn't hurt our business, it wouldn't hurt us legally, it wouldn't be a big deal, it's no big deal. But if someone saw that, yeah, please don't let them see that. Okay, cool, now we've identified something else. Okay, great, bring in the legal team. Yeah, they can't see anything. Dude, come on, okay, okay. These things are problematic, so make sure they go away. And by the way, the legal team may be able to get you those relational things that are more interesting. So without getting into any kind of political stuff, please look around the room for a moment. Look around, please look around. Now, if I were to say someone identified as female and attended SQL Bits, could I narrow down who was here really quickly? If I then also got, say, hair color and eye color? So there might be related information that is going to let you know what's going on. So you've also got to bring that in from the legal team. So all of that has to be done. And then you got to mark it somehow. 1, 2, 3, no big deal, maybe. Oh my God, don't let that out. Or, however you do it. I mean, you got to make those calls.
Yeah. And from there, that's really where we start to begin. Do we want to jump into catalog, or are we going to keep going a bit?
Sure, I don't care. Yeah, however you want to do it, man.
Let's go. So
he has to do the demos, so I'm like,
I have to do the demo part, so Grant can sit back for a second. So, where is it? So, start off with, we want to show you something today that's just a great way that we found for identifying exactly what we are going to want to do in way of tagging and finding our data. And I think I'm probably going to have to drag this over. Are we on a different screen? Yes, we are.
Oh, I love doing it. I love doing it this way. Here, let me get out of your way. So
there we go. Always love it when I don't think in advance to use the mouse and use the trackpad, because that's always a fun way to do it. So, what we're going to use today is Redgate's data catalog solution. So Redgate's data catalog solution lets us tag exactly where that data that we were talking about is actually contained. So what we first need to do before we go any further into any sort of cataloging work is to be able to have a live system, because what it looks like today doesn't necessarily mean what it looks like tomorrow. And it can be a lot of work to keep on top of that side. So once we have something in place, we can start to talk about the language we want to use. Because the language we want to use is really crucial as a first step. Having that framework that we can start to go within. And from here, we have a load of lovely little categories on the left-hand side and some very familiar sounding boxes on the right. So all of these values are things that we're going to want to apply, like whether something is a bank account, whether a gender, a nationality. These type of things are things that we typically see as a single value. A field is unlikely to be both a zip code and a date of birth at the same time. But something like information regulations, you might be, as Grant said, working under any of those regulations, but you might be working under several at the same time. There's no reason why these things can't cross over. So for those, we want to be able to add multiple values. And there might be business-specific language that you've got to use as well. It's not just about who, what, where. There might be other aspects you want to bring in. Once you've agreed that language, it's about how do you then anonymize it. And data classification is, or can be, a massive undertaking. So the last thing you want to do is manually click through every column in your database, adding exactly what it is, trying to figure out what column JX7 is 700 times. So what we do is we build some rules. Now, the rules are only as good as you want to make them. Take a little bit of work up front to refine them, but it should do 90% of the heavy lifting for you. So the idea is here, what do we want to match it to? Now, again, a lot easier with better naming conventions, because if we can start to look, in this case, for a healthcare rule, starting to match things like patient, or doctor, or prescription, things that are going to be able to trigger up that we're in a healthcare area. And then over here on the right, what values are we going to want to add? So if we're matching this criteria, after a bit of refinement, we may choose to move from manually applying these rules over to automatically applying them. Just being able to let this evolve. When new columns are added, picking them up. When new tables are added, picking them up. Being able to have that single sort of language and this framework over your entire data estate. The other one, just outside of the naming conventions or the data types, predicted information type. So effectively running through a sampling of the contents of the column and seeing what pattern we can match to it. Being able to see if, for example, if it's something at something.something, probably an email address. Being able to generate that sort of content out of there as well, also especially valuable and helps with those less clear column names. Once we've done that, we can either automatically apply those or we can manually apply them. And they're going to come out as a whole bunch of suggestions. And you use this in the first instance to really refine the framework that you want to have. So you might find that you're looking for the matching value for email, but you're getting a whole load of columns up as email do not send, yes or no. You don't want to anonymize that column necessarily, but it's matching because it's finding email. So then you need to start excluding values. The more you refine it, the more that scales across the estate. The more that it's just a repeatable process going across. For the purpose of today, I'm going to do the really bad practice thing of just applying some stuff in bulk without checking it. Yeah, because who doesn't like bad practice? So I've got a table that I want to work with for the workflow. Just going to apply some values, typical stuff over here, information type, that it's confidential. And as simple as that, I've started to classify some of my database. From here, if I come back in the overview, I've done a tiny little wedge of the database there by classifying that one section of my estate. I've done about a quarter of this particular database here. And when I come in, I can see all of these values over here. Anything that I want to work with, now I can start to populate out. And that might be a case of me doing some tweaking on some of these. So for example, this one at the bottom, company name. I also want to tag this in, and I want to specify that it's actually going to be an organization name. I want to say it's going to be confidential. And for me, right down here, one of the most important things I want to do is I want to specify the treatment intent, because I want to work with this going forwards, and I don't want to do all of this work twice. Last thing I want to do is spend all of my time cataloging it and then have to do the whole thing again to build out all the work to actually deal with it going forwards. So I'm going to say static masking. I'm going to apply that. And then over here, we've got some values. So we now know it's an organization name. We know it's confidential. And ultimately, for the purpose of this, we have static masking down the bottom here as well. Once I've got those, I can skip a few steps. Because what I can do is I can use that. So what it's looking for in here is something that I can give to a masking solution, something that I can actually say, this is the type of information that's present, and this is what I want to do with it. Once I have that in place, that's something that I can start to leverage. And the whole thing is perfectly viewable from an audit history point of view as well. Because it's not just about the doing the work, it's about proving you've done the work when you're talking about a compliance side. So being able to give that full audit history, that's great. And I can download that mapping file and then give it to the masking side. So, before we go over to masking, should we talk a bit more about the theory of anonymization?
Yeah, we got to talk more. Oh, ouch. God, I am old. Ugh.
I'm getting there.
I'm waiting.
It's taking a while.
I'm being patient.
There we go. There we go. We're back. Sort of.
Almost. You got to restart the slideshow,
There we go.
and then it'll go black probably.
Yep. Wait for it to get back into life. And there we go. We are back.
No, we're not.
We are now.
Now we are. Awesome. Hey, all right. So, does everyone agree we shouldn't have production data? I've got a story coming. Just hold on. Because I've got a real reason why we don't do it. All right, cool. Everyone agree that there's got to be some kind of logical process you go through to identify the data somehow. Even if you don't use our tool, you got to go through something kind of process, right? Awesome. All right. Well, once we've done that, now at least now we know kind of stuff we can do, but what are we going to do with our data? Well, I mean, you've got choices. You can do no test data at all. I'm sure that would work out great. All right, obviously that's stupid. That's like putting in one row everywhere. I mean, no one would do that. God, still can't believe we let them get away. Oh no, you don't need to look at our database, it's fine. Anyway, that's my lesson from that one. So fine. We're not going to give them no data or one row. And then it's down to what are we going to do? You can look at generated data or mass data. And that's it. I mean, those are your two choices. You can make it or you can hide it. And you've just got to make the choice on how you want to do it. Making the data, there are some tools out there. Hell, Redgate sells one. I'm not even going to try to defend it. It's decent. I use it. But it's not like a major tool I use. It's a useful tool because I can spit out some good fake data that looks okay, gets me where I need to go. Is the distribution close to what production is? Nope. You got a question?
I was just going to say this is a problem we worked on with a client a couple of years ago. Was generating test data that matches the distribution of production data. They ended up building a kind of data analysis system that looked at distribution of data, not just per column, but per group of columns.
Sure.
To try and make sure that the reality was, the test data matching.
So he was working. I'm getting to it. For those at home, I'll step in the light. We've got helpers reminding us to repeat the question. So he was saying is that he was working with a company previously that they built a system that analyzed their data in order to produce test data that in order to make sure that it was distributed correctly. I said that, right? Yeah. And that was easy. No. Okay. He said the answer you expect, no. So no, it's really hard. So generally, and I'm not going to say always, because we're working on some cool stuff. Generally, generating test data is harder and less accurate. It's just not going to come out the best way. So usually, what most of us do is mask the data in some fashion, right? Yeah. Most of us do. Okay, cool. Let's talk about this stuff in a little bit more detail. Get the sword out. +5 great sword.
You forgot your sword. This would have been a perfect time.
Yeah, I know. So it would have been the perfect time. Yeah, but I put it away because I don't want to break it. It's a little plastic sword. I need it for tonight. So, oh, go ahead.
No, I was going to
please.
say, you've got really one of the big challenges is looking at the data size that you're going to work with. Yeah, that was a key thing that came up earlier. I think you said about 30 terabytes. It's going to present an issue if, I was just talking to a guy literally just before we came up here, having to do a daily backup and restore of a 34 terabyte environment. And, it's a fun 10 hours. And that can be a little limiting to the process. So when we're looking at that and you want to recreate that, you've got some options. First off, you've got the generated data, like Grant said. You can stand up an environment, populate that out. You've got some pluses and minuses there. Might not look like you exactly expect it. Might not look like anything you're going to end up with at the end.
But you can make it quick.
Yeah.
Honestly, that's the one advantage. You can make it quick, or relatively quick.
Yeah.
Depending on how much you want to generate.
Yeah. You've got the option to subset your data. And as Grant said, no spoilers, but something might be coming from Redgate at some point. You could shrink the database. Now again, we may get to that in a little while.
Well, no, hang on. We don't want to shrink the database. Shrinking the databases are bad.
We're not going to shrink the database, but we're going to do something creatively fun.
No. We're going to shrink a database. Okay, no. If you do this with a copy of production, then you want to do that. And I know, every one of the DBAs in there just went, ugh. But that's okay because we're talking about dev, right? I'm not shrinking your prod database, man. Okay? We can do that. What's that?
Not subsetting the production data either.
Oh, but not subsetting the production databases. Yeah, well, okay. True.
And then you come to the last point of actually looking at the storage size you need. Exactly what are you going to allocate? How much space are you going to need for this? What storage are you going to allow based around there? And that can be a fairly limiting factor. So from here,
We're not showing the next thing yet.
no, we're not.
Okay. So how do you find your path? Because the important thing here is, look, the important driver here is I want to give a database to my dev team. Period. I want to. It's not, I know there are DBAs who don't, but I'm a weird DBA. I came out of development, so I've got a lot of sympathy for the development team. I mean, don't ask for production access. That's how the scary DBA came around. But my nickname is the scary DBA for anyone who doesn't know. It's real. I actually have a nameplate from the company that said that, scary DBA. Oh yeah, I kept it. Wasn't supposed to.
That's why it was scary, because you're stealing the nameplates.
Anyway, so I want to give you a database. Now, one way you can do it is I can give you a database, and now the whole dev team gets to work on that database. Who's worked that way before? Who loved it? One hand. Okay, cool. Good. The initial one, the number of people who were in the room who had worked that way was about a third. And it's more than 10 people, so it's what, 40? I haven't counted. Call it 40. Just for those at home to know how many people are here and how many people are raising their hands. Cool. So shared databases are kind of somewhat problematic, especially anybody who's done a shared database with multiple teams on one database. Has anyone done a shared database with multiple teams on one database that had cross dependencies between the teams so that if any one team made a change, it burned the other 4 teams to the ground? Yeah, there's 2 hands up. Yeah, and mine, by the way, because, 3, 4. Okay, hands are sneaking up because people are suddenly going like, yeah, I've blocked this pain out of my memory, and now you're bringing it back. Thanks, I have to go see the therapist now.
You're literally causing traumatic flashbacks at this point.
Yeah, because shared databases become a nightmare when more than one team is involved, or more than one application, or worse yet, more than one application and more than one team on more than one application. Oh, yeah. Fine. So we'll do scripted restores. You get a restore locally on your laptop. Honestly, that's where I want to go. I do. But that 10 terabyte database is not going to fit on my 1 terabyte laptop. Babe. Right? So, okay, we're out. Containers, no problem. It's still 5 terabytes or 10 terabytes, man. I don't care if it's a container or not. All right, cool. We got another problem. Virtualization. Solves a couple of problems, doesn't solve all of them. So now we're in trouble. But before we go on, because we're going to show you how to solve all the stuff that we were just saying. But I've got another story. So no, really, there I was, working with a developer, and at the time, the company, we worked off really simple stuff, and so we gave the full production database to the development team. One of the developers, here, let me move over here so that there's actually light for this one. One of the developers was working on email automation. Oh, you think you know where this story's going. Actually, you're kind of right. Said developer got bored at work frequently. And when he was bored at work, he enjoyed looking at adult-themed images. And while working on the email system, would send himself various adult-themed images because it gave him a giggle. Yes, we sent porn to our entire customer list. That's not the cool part of the story. The cool part of the story is he didn't get fired, because I would have fired him, because I had to sit through a lot of meetings explaining why said developer was able to send email to the entire customer list, and I kept explaining over and over again, because you told me to let him. Because, yeah, I had asked, couldn't we just sort of mask the emails or something before we give the data to the developers? Oh, no, they would never do anything stupid. I have that in an email, by the way. I kept it. So, yeah, for real, we want to mask the data before we give it to the dev team. And it's not picking on the dev team. This is not, well, we're picking on one developer. I have no problem picking on this individual. And they didn't last long at the company because I picked on them constantly. Sent any interesting emails out lately? Oh, yeah, God. I was angry. I won't lie. But anyway, Redgate's here to help. We already walk you guys through Data Catalog. Data Catalog is a great tool. It's fantastic because it works a lot the way the business understands the data. It works a lot the way the legal team understands the data. And so it gives you the ability to start marking the data that has to get marked, right? So we know which data is problematic. We know which data we really, really shouldn't let people have. Even our common sense stuff like email. Right? I mean, it's a ridiculous story, I grant you. True, by the way, 100% true. Embarrassing. But that's what catalog's all about, is getting that mark out there. But now, how are we going to deal with all the other stuff? We talked about time. We talked about size. We've got some cool things.
We do have some cool things.
Go ahead.
So, when we look at it, we need to figure out exactly how we're going to get it. So like I said, it's great to be able to know where it is. It's great to know how to anonymize it. But how do you give it to someone? How do you wrap the whole thing together in a process that is repeatable and clear? Bless you. So, to start off with, we look at SQL Clone. Now, SQL Clone is a way that we can take production and wrap all of the good stuff that we want to look at in the middle part before we give it down to development, testing, whatever purpose you want to use it for. But effectively know where the data is, know what the data is, and be able to deal with it in some way. From there, this is where we start to see that data catalog section coming in from the other side. Clone is the end state that we're going to reach. Data catalog comes in from the top, and that file that I exported as we finished, that's what we hand over to the masking side. The masking side is then going to be all of the actions that we want to do. But ultimately, that's still got to keep realistic data. That's still got to keep something that is going to keep everybody happy, still going to be usable, still going to be representative, not going to be a load of gibberish that you're going to pass out for a database that looks nothing like what it started with. And how do we do that? We bring the source data in, and that's where we apply the masking. We're applying it into the source. So everything that we're doing going off the back of that has already got the masking side baked in. Because ultimately, the last thing that we want to do is end up with data that's going out there outside of that production remit before the anonymization has been done. So from there, we can go to the last part of the demo. So you'll be pleased to hear that I actually found my mouse during the last bit. Don't have to suffer through me using a trackpad again. So what we've got is this mapping file down here. And this is what we're going to pass over to Data Masker. This is going to be all of the good work that you've done in Data Catalog. Now, for this example, obviously, I just added that one column definition. I added the one thing I wanted to do. So from here, I navigate into the environment that I want to use it with. Same database here. And I connect. And what that has now told Data Masker is that for this environment here, I've got a rule. And that rule is going to be that I want to take company name, and I want to mask it with a data set of company names. Because it's already picked up on the static masking flag that I've put in. That tells it it's sensitive and it needs to manage it in some way. And the information type I've selected gives it the instruction that says, this is what we now need to anonymize that with. So all of the hard work that you put in up front, figuring out what was in the column, where it was, you carry those instructions over. You don't then have to reinvent the wheel at this step to bring the masking side in. Because the last thing you want to do is all of that work twice. And rather than watch me sit here and build every column into something else, what I'm going to do is cheat and show you very much a Blue Peter, here's what I made earlier style. So we've got a masking set. Now this is built around that same database, and it just expanded out that logic. So we've still got in here the company name file, but we've got first names, last names, street names, all of these different things. And all of these data sets that we're using are pre-built into Data Masker. There's something that you can get, but you can build your own as well. So if you do have that business-specific use case, you have medical conditions you want to list out, whatever it is in there, selections of names, you can bring that side in. Literally, it's a text file saved in the Data Masker directory effectively in the right format. But we do give you a good place to start. So you've got things like account numbers, you've got names. My personal favorite that I never know why we include is endangered mammals. I really have never seen that become a suable issue under any sort of information law. But you've got geographic splits, gender splits, everything else. And that's great for the substitution part of it. But not everything just wants to be a replacement value. Databases are a bit more complex than just slap value A and slap in whole B. So we start to build out a bit of logic. And we want to keep the realism there. Now we've got a little clever thing over here where we're dropping these in, and these rules, where they're edged in, are going to take place after the last one. So in that first pass, all I replaced with the first names was all of those with female names. But we also want to keep it representative. So from here, I also happen in this database to have a gender column. So I'm going to then go through as a second pass and bring in the male names. Now, reason we don't say, let's go female to female, male to male in this scenario, someone's chosen not to declare a gender, even if the column's been missed, we're going to persist original data. So we blanket mask with a value, and then we pick out a variance we know. We have a good idea then. Next thing, if my name has become Grant's name, the last thing I want is Joe Blogs as the email address. I want it to look like it's real data. So I take the masked values I've used, my name's become Grant's name, the email address is also going to be grant.fritchey. Because the last thing we want is, again, for it to look like fake data. The whole point of this is that we're giving stuff people can work with. A couple of other rules. We've got a varchar 2000 column, and God knows what someone's stuck in there. There could be credit card information, there could be email addresses, could be God knows what. So in here, we randomly replace all the text. Alphanumeric characters, keeping the presence for development and testing, removing the risk. And the last one, we have some records that are in 2 locations. So over here, it's in a customer table. Over here, it's in a customer notes table. We link the columns. So we have an ID column here, so after my name becomes Grant here, we also copy the value over. The referential integrity stays. We have workable data sets. It's not just a case of slapping the replacement values in.
And the exact same data distribution, exact same data distribution.
There we go. Grant is very happy with this.
Yeah.
So the last part comes down to how do we slap a bow on this and tie it all together. We go to SQL Clone. We're going to create an image to start off with. Today, I'm going to use SQL Server. I'm going to pick the location I want to work with. And the first thing that's going to flag up is my data catalog work. Just a warning, really slapping me in the face that there is confidential data in here because I've said so. Yes?
With data masking, how would it deal with denormalized data? So, for example, you've got the same value in 2 separate rows. They do represent the same thing, but they're not obviously known from a data integrity point of view. They understand.
You can link the rows and you can link rows and columns, and you can get really. We could spend 3 hours on Data Masker. It is that sophisticated. Yeah, we're getting close to about 5 minutes.
Yeah.
Yeah, the question was, if they had denormalized data, can we also link that together? And the answer is yes.
Yeah. This point, this is where we want to bring the masking stuff in, because ultimately, we want to create that image anonymized. Last thing we want to do is allow us to persist. If we want to do other things in here, modify the image we're about to create, we can do. But for today, I just want to mask it. I'm going to pick a location it's going to live, and I'm going to give it a name. We'll do it if I click on the right box. So this part is going to take about the same time as a backup or restore. So the guy I was talking to earlier, he's still going to have that 10 hours. But he's not going to have that 10 hours for every single person that wants that database. We're going to do this once. One-time only action, about that time, and we're going to create ourselves an image up here. And this image is exactly what we want it to be. It's a like-for-like copy of the database. And we can work with up to, I think it's 64 terabytes of data that we can work with in this image. And this can then be the source of absolutely everything going forwards.